You want to know why seasons occur? Okay, first I want you to picture the orbit of the Earth. Imagine the shape. Draw it out if you want. Put the sun in there too, I'll wait. Done? Alright, how many of you drew it like this? A long ellipse with the sun off center a bit. You may think this would be a pretty good explanation for the seasons. When the Earth is closer to the sun, it would be summer. And when it's farther away from the sun, then it would be winter. When I was a kid, this is what made sense to me, but it gets a little more complicated when you remember that when it's summer in the northern hemisphere, it's actually winter in the southern hemisphere. And the time of the year when the Earth is closest to the sun is in January. Not exactly a warm season for those of us up north. So what's the deal? Well, this image of an egg-shaped orbit is actually wrong. But isn't the orbit of the Earth an ellipse, an oval? That's what my teacher taught me. Okay, so it is an ellipse. The orbits of all planets and moons are ellipses, but the shape of each one varies, and the orbit of the Earth is actually fairly close to a circle. The difference from when the Earth is closest to the sun versus farthest away from the sun is actually pretty small compared to the orbit as a whole, so it doesn't really have much of an effect on our climate. If this is all sounding new to you, don't worry. It's a common misconception. Look, this is the science book that I used in 7th grade, and it really makes you think that the orbit of the Earth is this long egg shape, where it's really close to the sun at one time of the year and really far away at another. The reason for this is that people want to highlight the shape of the elliptical orbit, and so they exaggerate the shape of the Earth's orbit. Okay, so if the seasons are not caused by the elliptical orbit of the Earth, what's the reason? What is the reason for the seasons? Part 1. The Earth is round. I know it sounds crazy, but the first concept that you need to know in order to understand the seasons is that the Earth is not a cube. Obvious, right? But let's imagine for a moment if the Earth was a cube. How would things be different? If the Earth were a square, then the sun's rays would all hit the Earth at around the same angle, like this. See how they're all hitting at about 90 degrees? If that happened, then all of these places would more or less have about the same temperature. But the Earth isn't a square. It's round. It's a sphere. Because of this, as the rays from the sun hit the Earth, they do so at different angles, depending on what part of the Earth they hit. In this example, the rays hitting Florida are almost 90 degrees, while the rays hitting Alaska are about 30 degrees. The parts of the Earth that get a direct hit from the sun's rays receive more energy from the sun, while the parts of the Earth where the sun's rays hit on a more shallow angle receive less energy. Check out this experiment with a flashlight. So right here I have a concentrated beam of light on this grid. Now the light is pointing directly at the grid, at about 90 degrees. Notice the shape and size of the lit area here, and also pay attention to how bright that spot of light is. Now, as I move the light to an angle of about 30 degrees, notice how the shape and size of the lit area change, as well as the intensity of the light. The same amount of light is being emitted by the flashlight throughout, but now it's being spread out over a larger area, so the energy, or brightness, is less intense throughout. This is what happens to the sunlight on Earth. During the winter, the sun's energy is less intense because it's spread out over a larger area and not hitting the Earth as directly. Part 2. The Earth is tilted. Okay, so the Earth is round, but the Earth is also tilted at about 23.5 degrees. The reason that seasons occur is because of this tilt. Here, let me explain. Notice how the northern hemisphere is pointed toward the sun, while the southern hemisphere is pointed away from the sun. So because the Earth is tilted, when it revolves around the sun, the northern and southern hemisphere trade back and forth between being tilted toward the sun and away from the sun. So this concept here, that during different times of the year, a hemisphere may be pointed toward or away from the sun, that is key to understanding the seasons. Part 3. The Earth has seasons. Let's take a look at the northern hemisphere to break down what's happening to Earth during the seasons. During the winter, the northern hemisphere is tilted away from the sun. Take a look at the angle of the sun's rays here. It's pretty shallow, which means that it's not receiving as much energy from the sun. If an area receives less and less energy from the sun for a long period of time, then it goes into winter. Now let's hop to the other side of the Earth's orbit to check out summer. Notice how the northern hemisphere is tilted toward the sun here. Now the northern hemisphere is receiving lots of direct sunlight and energy from the sun. which means we get summer. Now, fall and spring are transitional seasons that land right in between summer and winter. So they get about the same amount of energy from the sun as the other. They differ based on which season they're transitioning out of and into. Take a look at the southern hemisphere here. When the northern hemisphere is in winter, pointed away from the sun, the southern hemisphere is in the summer, pointed toward the sun. This is why people in Australia celebrate Christmas in the summer, because their summer is in December.
Review time.
Okay, so a bit of review. The Earth is round, so the sun's rays hit the Earth at different angles. If a part of the Earth receives direct sun rays, like 90 degrees, then it receives a lot more energy, and it will be hotter. If the sun's rays hit a part of the Earth on an angle, it'll receive less energy. And if we move closer to a pole, the angle of the sun's rays get more and more extreme, which is why it's so cold at the north and south poles. The Earth is also tilted, so at different times in the year, one pole of the Earth is pointed toward the sun, while the other pole is pointed away from the sun. This tilt is the reason for the changing of the seasons. If the Earth wasn't tilted, then we would experience one season year-round. All right, that's it, folks. Hope you learned something here. Remember, be curious and ask questions. See you next time.